Hi, this is week 4 and I'm documenting and talking to myself about machine learning and AI engineering, the things that I've learned over the past week, and this is what I've learned these days. The new thing for me have been ensembling methods. So to imagine, I can build a model that is not underfitted and not overfitted, but there are different types of model that you can build using the same data set and you will have different results. For example, if you use logistic regression, it's going to give you one result. If you're going to use decision trees classifiers, it's going to give you another result. If you use support vector machine model, I will have different result from those previous ones. And if there is difference between models, logistic regression, decision tree classifier, we have SVM or whatever it is, it doesn't mean that one model is better than another, because each of those models have their own way to find to basically learn from data and generalize that on new patterns. So each model has something useful that can be used later down the line, and taking something unique from each of those models and combining them into one model gives me unfair advantage, because each model has something useful that probably another model would not simply see. And this is what ensembling methods do. They combine all the useful information to create one wholesome model. There are a couple of methods that are used for the most part in machine learning and are very common. One method is bagging. And bagging is when multiple models are trained on different bootstrap subsets of the training data. Imagine you have a bag of numbers and you need to create models with those numbers. So you take out one number from the bag, then you write that number down and you put that number back in a bag. Then another time you pull out another number and you write that number down, even if that number is the same. This is why bootstrapping is the process, and there are two conjunctions basically that you need to remember is with replacement. It means that you put that back in a bag, and there is a possibility, there is always a chance that you can take out the same number as you already did. But the whole bag is like a training data set. It has the same numbers. You just pull them out, write them down, and you put them back. And from those combinations of numbers, you create those models. And it doesn't matter if the numbers in the models will be the same. The idea of bootstrapping is to create different subsets, different models that could contain the same numbers, but they will have useful information because they will be different anyways. If there are millions of numbers, it cannot pull out the same numbers from each for each model, and all the outputs you will have from those models, from those combinations of numbers, will be either averaged in the case of regression to find the best model, or voted in case of classification by random forest that is used alongside with decision tree classifier. Another method is boosting. And boosting is used to reduce both bias and variance. So basically the idea of boosting is subsequent. Each model that are called weak learners or base estimators, and those base estimators, they are decision stumps. They have only one question and two options. That's it. Therefore, they are going to be underfitted extremely, but every following model will be learning from exactly the errors of the previous model and will be improving upon them. It remembers only bad side of that model. It does not try to remember good side, because it wants to learn only from mistakes and not rebuild another model because it remembered that model looked good in this particular scenario. It actually just simply learns, and every subsequent model thus is better. And the final prediction is a weighted sum of all the models. And the third one is stacking. Stacking is very easy to understand. Stacking is basically when a couple of models have their predictions, you use those predictions, those outcomes, as another feature. So basically another column of information is going to be either 0 or 1. And based on those features, though, if we have, for example, 3 models, SVM, we have logistic regression, and we have a decision tree classifier, those 3 models will give us 3 basically outcomes. Those 3 outcomes will be turned into features, and all those outcomes are learned from meta model. And meta model is the basically final model that united all of the basically predictions, all of the features from those previous models into one. So it's basically one final model, and it learns from that and gives you the best results. So this is the main feature to remember, is it turns all the predictions in the features, basically the columns of information of each model is another feature, and it learns from that and creates the best based on the information it has got. And also I would like to tell myself that I got pretty tired during all this career path journey and all this stuff. I found myself quite challenged because I've finished all the learnings, all the theory, all the exercises and everything, especially in the end when it got very complex in all the exercises and all the basically operations you need to think on, algorithms and structures. But now I've finished it, and now I am going to be working on my final portfolio, and I'm going to be sharing my progress and the whole process and steps I'm doing in a portfolio in the nearest future. And this has been me trying to explain what ensembling methods are and how to implement them. Here I only try to explain to myself what different ensembling methods are, and so I can remember.